Welcome back, everyone. This is video 11, adding enemy bombs, scoring, and adding players' lives. This one's going to be a short one because, again, I cheated a little bit. I went ahead and did some of the scripting and the code for some of the stuff off stream. It was just, I was a late night when I was working on it. I was tired, and I didn't want to make it a very boring stream, more boring than what they normally are. So anyways, let me just show you the progress we've made on the last video. If you were watching the last stream, we were able to get the enemies moving down. We had the players shooting missiles and killing the enemies, but I did not implement the enemies shooting bombs or dropping bombs back down at the player, nor did I have it where the collisions on the defense towers would work at all. I decided to shorten up this video series to make it easier than what we had planned to do. Is I just set up a hit point system on the defenses. They're worth 10 points each. Player gets 3 lives, so it starts with the player controller starts with a 3-point, basically a hit point, and if he gets hit by 3 missiles, the game's over. So it's the equivalent of 3 lives. In the top left corner, we've got a scoring system, and we also have the live shown in the top right. Scoring's in the top left. And so let me go ahead and play this. Hit play here so you can see. And I'll maximize the gameplay so you can see it better. Okay, as you can see, the number that's shown on each defense is the hit points. You'll see as they get hit by a missile, the point systems will go down. Now, I can go ahead and fire away and shoot some of these enemies out. Let's get that rolling. We get the ones you'll see also. Whoops, game over. See, I got hit 3 times. I'm over. It's done. I don't have any way to escape out of the game, so if I were to build this game and ship it right now, everyone would be stuck in a full screen game mode, so they'd have to task manager out of the game. So that's something we're going to fix in this video. Let's play it again. I didn't mean to die that quick. It's a very complex thing. Okay, you see the lives. The bomb went through and the lives went down to 2. It's in top right. That shield got hit. I also added, you notice, as the enemies disappear, the speed at which they come down increases as well. So as there's fewer and fewer enemies, they'll start coming down. Also, when they hit the shields, they shrink the shields, and so they can, even though they're not killing it with a blast, they are, in fact, knocking the shields down. So I'm down to 1 shield right now. See, they're speeding up. Boom, boom. My last one's going to be gone here in just a minute. Yeah, it's gone. And I might actually win this. Boom, I won. So I just have it set where it shows the you win message. It doesn't really exit the game at this point. It did score 5,000. I killed every enemy. That was 5,000, 100 points for each. That's the other thing. We got 100 points per enemy. That's tracked with the score system. So I'm trying to think, what else did I add? The scores, the lives, the enemies dropping bombs, the shields with the hit points. So the next thing I want to do is program in at least a couple of options. One, when it says you win or the game's over, I want to have an option where you can like restart play again, which would reload this level from scratch and you can start again. Really would not be it's not going to be a continuation. It'll just you can start over. It's kind of a single level game right now. And the way it's been designed, it's really not very dynamic where it builds. We don't have different enemies yet, or they're all the same. So there's no sense investing a whole lot of time in this project. The main thing is to finish out all the features, even if they are very simple right now, like they are. So let's stop this, and first thing I want to do is add the ability to escape out of the game. And let's look at the scripts we have on here so I can show you what was added. I probably should have had one before, and a lot of this functionality could have went in a common script called game controller. But this is the script that I'm going to use to, it's actually tied to the plane, which is the main playing surface here. You can see right here the script component. So let's go ahead and modify that script. That's what we currently have in here, which basically is when I started to add the scoring system and showing the lives. I set that up in the game controller. I wound up having to, in order to implement the way it shows the score and lives on this scene, is it uses a UI element. If we go to Game Object, UI, there's this text element. And as soon as you add your first UI element to your project, we can see it right here. It adds a, Unity will add a canvas object, and this other component or object here called an event system, and those are required for this to work. So the first time you add any UI element, you're going to get really your element you're adding plus 2 additional objects for the game, which is the canvas and the event system. Now, I renamed this to UI canvas. By default, it's just canvas. But I have a score text, which is basically the UI text, and then the lives text, and I have a game over text, which is not shown until the game's over, and it will either show, you know, you win or a game over message if I were to lose, which you saw the first time I ran this. So we're going to add to this. Let's go ahead and add the escape key, so you can at least escape out of the game. At the same time, we'll add maybe a prompt, a message, note a message that will display underneath either you win or game over. It'll say play again, or press Y to play again, and or escape to quit is what we'll do, something like that. Just something simple. Alright, so let's jump to this right here. And now this needs to be in the in this update function. The update function is called once per frame. No matter what script we're in, these update functions that are in all these scripts we have, they're all being called once per frame. So, I mean, we effectively, you can put, sometimes you can put everything into one script if it makes sense, but sometimes you have functionality that's tied to a certain game object. For example, the missiles or the bombs for the enemies and the player, they have their own scripts, because once you instantiate those items, you want them to go off on their own and let the script handle what it needs to do, move it around the 3D world. So, alright, so how do we get user input? Well, it's going to be similar to the way we were getting the access, the horizontal vertical. We're going to say if input dot, and this time we're going to use get key instead of get a button or get, I think we're using get access before. This time we're using get key, and there's a parameter you pass to it. It's called a key code. Key, you can see it pops up right away showing what the syntax of that function and get key is. But the value that needs to be passed in it's of type key code, and key is the actual variable it uses inside get key, that function it's built into it. But anyways, the key code actually is it's also predefined as some constants. There's a structure that defines some of these that are ready to use. So we'll just type in key code and a dot, and you can see Visual Studio will drop down a list of the predefined constants, if you will, for certain keys that bind back to the actual key codes in the computer's keyboard and mouse, etc. So we got the escape key right there. That's the one we want. If key code.escape, then we're going to do something. So basically all it's saying, if the user hits escape while this game controller script is running, we're going to act and do something. Now there's a built-in object called application, which every Unity project will have, that when it's built and you run it, there's an application object that's defined. It's actually static, which means we don't have to actually define an instance of it. It's already defined for us statically when the project when the game runs, when you actually execute it. And you hit the dot operator to access any properties and functions, and conveniently there's a function called quit, and it says quits the player application. So the player application is basically our application. Depending on what platform you're on, it's going to quit the player that's actually running your scenes and all that. So it's as simple as that. We should be able to just put that in there, and we've built in the functionality just to escape out of the game at any time. It doesn't necessarily have to be at the end of the game, because this game controller again is running this update function, or Unity is running it once every game frame. So let's go ahead and test that just to make sure that works before we start defining, the yes key and some other things that the user can press. So I'm hitting escape. And escape is not working, so we need to figure out why. Why is it not working? Live Santana 0, we got the game over. Alright, so that didn't actually work. So again, it's another crippling part. A simple little thing we're trying to do, escape out of a game. Why would it be so difficult, Come on. So there we are, back to the Unity manual. Well, actually what I want to do is search on Google. How to create an exit menu from a Unity game. Actually, let's do this. Let's go back. I saw something about that quit scripting. Just quits the player when the user hits escape function update. If input.get key escape application.quit. Oh, wait a minute. Quits the player. Quit is ignored in the editor. So we're running the game from the editor at quit. It's important. In most cases, termination of applications under iOS should be left at the user discretion. Consult Apple technical page QA 1561 for details. Okay, so maybe if we build it, it'll work. So, well, let's build it. All right, so let's build and run this thing. I want to see if that's true. Now, I've defined in the player settings for the build, I've defined it to be a full screen window using the native resolution of whatever the user's desktop is. So everything will automatically be scaled up. By default, Unity has if you don't turn it off, it's got a little pop-up window that comes up where the user can pick what resolution they want to run in and do all this stuff. And to me, it's just kind of a hassle. You got the splash screen made with Unity. It goes full screen. So if we hit escape, yeah, okay, so that worked. I hit escape, it worked. So, okay, so it doesn't work in the player because you can stop it through the play, and so that functionality, it must check if you're in the editor here. It won't work. So it did work. Okay, so that's one less thing we need to worry about. Now the other thing we want to do is add an option for the user to be able to restart and play again if they want after the game's over, or even if you win, if you want to play again. I almost don't want to reset the score. It would be nice to carry it over, but the way I have it designed, it's tied to the scene. essentially to restart the game, we're basically reloading our scene, which is called gameplay right here. It's at the top. That's our scene name. And what it does is completely destroy the old gameplay object scene, the scene object, and you reload another one. And so all values that were previously in memory and are destroyed at that point. There is a way, I'm sure, to pass information between scenes or to store information outside the scene. I haven't researched that yet. That's something I'll look into on the next project because we're going to have a multiple scene application with a full UI to start the game, and rather than have the game just start right away, it will be like a traditional game that would have some sort of a menu, a UI, 2D UI menu, where they can access, start a new game, or view the help. Maybe we'll come up with some options, but when we get to that next project. Anyway, so let's. Simplest thing we want to do right now is just allow the user to restart this game and do it again. So let's look at our, the canvas. And I want to see if I can add, let's see, the game over text. Okay, I just wanted to see where that was. I had to type something in there. By default, I had nothing in there. So let's add another UI text. And okay, everything's centered there. That's fine. We got an anchor, a basic anchor that anchors it to the top left, top right, of the screen. But and then you can fine tune it with these anchors here. It's kind of like a border, and then you can also set with the position X and Y. You can just set it directly. Let's see, where am I wanting to go? Right here. Okay, so let's go down -50. Actually, that other one I want to move up, the game over text. Let's move that up to, that's a little too high. So 50. And then this other one, we won't have to push it up as high, or I mean as low. We don't have to drop it down. Set it there, and on that new text, it will say, press Y. No, R. We'll make it R for replay. Press R to replay game. I guess we'll leave it at that. Simple little message. Just capitalize that. Okay. Set our font size to, the other one was 24. We're going to go like a little less than that, 20. And 320 by 75. And we'll change the color. Right now it's black. I don't know if we want to do a red. It's kind of hard to see. Blue maybe. Yeah, we'll do a variation of blue. Probably need a darker shade of blue. Do that. Press R to replay game. That's all. Alright, so we'll leave it at that. It's not the most appealing colors, but we'll at least have it programmed where you can do that. It'll load. Okay, so we've got that done. Let's name this one replay game text. And we don't need to really put a tag or anything on this. It's just for information purposes. So let's highlight this, copy. I'm going to cut that out. So initially, that's not going to show. Same with the game over text. Cut that out. Let's find the script. Where all this happens. Let's go back here. Okay, we're going to add another. Got these functions here. They're set public, which means they're accessible outside this game controller. When you create a reference to the game controller script object, anything that's public you can access and code from another script, just like we could access anything public in Unity where it shows up in the inspector. So that's how you expose functionality in one script to other scripts. Anyway, so we're going to create a function here called public void show replay message, and it's going to be replay one other thing we need to add, the game controller itself does not actually have direct access to the UI text controls or game objects that are on the UI. So we have to create these public variables of type text, which is the UI text. Let's call this replay game text. And by doing it like that, we just drag the UI control, the 2D UI control, into the inspector in this property slot that shows up now that we created it public, and it gives us, when a script is ran, it gets a reference then to that UI control that way, and then it can use it within. Then it can access properties and things on that control through scripting by referencing this name that we've defined here in this script. So down here in the show replay message, we'll say replay game text. That's the one we defined up there. Dot text is the property that you want to access in order to assign a string to, and that's when we're going to display the press R to replay game inside that text. By default, it's going to be, when the scene loads, it's empty, just like the other ones are. And so when they hit R to replay the game, when we reload the scene, it's going to reload everything from, when it first loads. So we don't need to clear it out or anything, because it'll be cleared out when the scene loads. We don't have to worry about that message, residing or staying on the screen after the scene gets loaded. All right, so let's go back to, now that's really the only thing we need to do there. Let's go back to Unity. And that was the game, should have been the game controller script. Oh, that was on the plane here. Still compiling, that's why it took a bit. And you see where I added, under the game controller, it added another property here called replay game text, and it has nothing assigned to it, but it's looking for something of a text type or control type, so object type. So these three are already set up, and I just added this one. So what we need to do, it's just as easy as on this replay, just click and drag kind of fast so that it doesn't switch to that, and just hover over there and drop it in there. You'll see, puts a nice little reference to that in there. So it's good, and it's got the little symbol. It's a T. It's an orange or yellow, box with a T on it for text. So that's all we need to do for that. Now the other code we need to look for is where basically when the player's live, it should be in the player controller. Yeah, and this is where we have the code here, the other.game object. It's doing a check here that when these bombs are dropping from the enemies and it crosses the trigger boundary of the player controller, this function here on trigger enter is called. And there's several things we're checking for. Initially we had it checking for collision with the left and right wall, so player controller cannot go past those two walls. But now we also added, this is something I did off stream yesterday, and so I added this here, and essentially what it's doing here when the bomb is hitting, making contact with the player controller, it jumps in and does this code in here, and this is how we reference or create a reference to the game controller object. We define a variable, which I just call GC for game controller, of type game controller, because as soon as you add a script, every one of those scripts become a new type, a data type in your project here. And granted, it's a script type, but it's not like an image or a resource or something like that, or an asset. It's still considered an asset, but it's a script type of asset. So anyways, we create a variable GC, and we use this function here called find object of type, and in brackets, less than, greater than, or brackets, we put in the type of object we're looking for that's already been instantiated or defined in our game. It's not going to pull the raw script file. It's going to look for that instance that's already been created within the Unity scene or somewhere in the game. And so there's only one game controller. That's why I can use this find object of type, because I'm only going to have one game controller ever. I'm not adding this script, game controller script, to any other game object in there other than the plane, or the object labeled plane that's been named plane, which is our ground. So there should only be one reference. That's what I'm getting at. And now that function is part of the built-in game object, and it's been defined as a static function. The reason I know that is because when you define a static function, you don't actually have to create an instance of this object before you use it. So what I mean is, like, I didn't have to, like I'm doing with this game controller, I'm creating a reference to it. I don't have to create a reference to the game object. It has some methods that are defined as static, and that means you can use them directly. Just type the object name, which is game object dot, and the method type, and it's static. If it weren't static, we'd have to do like game object, GO for our variable name equals new game object, basically create an instance of game object, and then assign something to it. It would require more lines of code, but sometimes it makes sense to have static functions, especially ones that are used so common like this. So anyways, without getting into a whole lot, it checks to make sure that a game controller instance has been found by doing the GC not equal to null statement. And then it calls in this case, if the bomb hits the player, then it calls the remove life method or function that I wrote in the game control. And all it does is it takes, if we go back and look at that, I don't know if you've seen it. I've got a public int live, so out in the inspector, if we go back to plain and look at this game controller script, lives is defined right down here as 3. So I did it that way so that I could easily go in here in the inspector and easily change or increase the lives. I could say we got 5 lives if we need it, and I wouldn't have to go back to the script to do it. But anyways, that's a number that's fed into the script and assigned to this lives variable when through the Unity inspector. And then when this start is ran, which is only ran one time. Start is only ran one time in every script. The first time that script is actually instantiated or an instance of it occurs in the game. So that will run runtime. I initially set the score to 0. And so lives are set from externally from the inspector at 3. And then when this remove life function right here is called, all it's doing is, this is a shorthand for saying lives equals lives minus 1. Just doing lives minus minus is a standard shortcut in C#. It's also in the C++ language, but it just subtracts 1 from whatever value is currently in lives, which starts at 3 and it would drop it down to 2. Next time you get hit, the 2 would drop to 1 and so forth every time remove life is called. Now, let's go back to the other script, player controller. And every time remove life is ran, since it is subtracting from lives, there's a check to see, and I have a public function created called get lives left, which will return back the number of lives left, or the value that's stored in that underscore lives variable, and it returns it back, and we're checking to see if it's less than or equal to 0, and that's when we destroy the game object, which is the player controller. We show the game over message, and that's that. So the other thing we also want to do here now is display the replay message. So that will show up on the screen. We can just add it right there. And so now it'll do those 3 things. When player lives is less than or equal to 0, it kills the player controller, takes it off the scene, and then displays the 2 messages. And at that point, you know, the user can hit R to replay, which will reload the scene, which we're about ready. We're going to script that in just a second. Or they can hit escape, which we've already scripted, and that will just close the game. So I guess I could modify that script, the text, to say press R to replay or escape to quit. I think I will. We'll go back and change that. Okay, now the other thing I want to also do is we need to find where when you've killed all the enemies, and that should be done. I believe it's in the propel missile function. Since when the missiles are the propel missile function is tied to the player's missile that's launched, not the bombs that are dropped by the enemies. And so that script runs on every missile that's launched. This script, a copy of the script is instantiated or created along with that missile. And so again, we're using we're getting a reference to the instance of the game controller when we collide. And this on trigger enter, we collide with a game object enemy. We will get an instance of the game controller object, and then we're going to add to the score. Basically, we're going to add 100 to the score. That's where I created this public function called add score. Again, it's in the game controller. If we go here, add score, you pass in the value, which is an integer, which means a decimal number, nothing with a fraction or floating point or anything. It's a whole number. Pass in the value. All it does is add that to the score. So if later on we decide to take this game further and have different enemies that are worth different value points, based on the enemy type, we could pass it a different score value, and it would automatically add to the score. And then of course, show score is called. The show score and show lives are never called from other scripts. The other scripts just use the add score and the remove lives and get lives functions to get information or update the actual values. But in this game controller, since update is run every frame, which could be if you got running 30, 40, 50 frames a second, the scores and lives are updated that many times a second. But so that's where the actual visual update on the screen is done. This here is done in memory to it's called a variable. A variable is basically a label for a memory location, and it stores a value in the memory of the computer. So that's basically how a variable works. And so, yeah, these functions, add score and all that, are used. So what I'm looking for is the code when, let's see, move enemy, spawn enemy. Okay, so that's right. I added it in the move enemies instead of on the missile, because the missile really didn't have any idea. The missile propel missile script, it can just detect when it's at collision with an object, and if that object is an enemy, it can then act on it. But it doesn't know how many enemies are out there. All it knows is that it collided with an instance of the enemy, and so that's all it can do is destroy that, enemy that it collided with. So the move enemies, I have this function called find enemies, which basically what it's doing is each time an enemy is destroyed, find enemies is called continually in this update function here in this script, down at the bottom here. And so it's always getting a new list, if you will, of enemies and adding it to basically a list in memory called enemies. I have it called enemies. And so it's finding all the game objects with tag enemy that still exist and rebuilding that list every frame of the game. So we have an accurate representation in this enemies list of how many enemies we have. Now, there's one check it does after it builds that list with this statement. And they're all stored. It checks the length of enemies.length. That returns a value to tell it how many objects, basically, or how many enemy objects are in that array called enemies, or that list called enemies. And if it's less than or equal to 0, which means if we've killed all the enemies in the game and there's no enemies left when we try to find game objects with that tag enemy, then we know we succeeded. We cleared that level. And so what I do at that point is, it does that check and it executes this little block of code here. These 4 lines. It gets a reference to the game controller object, and then it displays the show winner message that we won. And so again, after this message, this is another place that we want to show the replay message, so that the user or the player of the game has the option to press R to replay again, or, excuse me, I got like gas or hiccups or burps or something. I'm trying to hold it in. Yeah, anyways, we'll show it there. You get the point. We've got to show it there as well. I'm not going to get into how that's a basic function. It's just displaying text. All right. So let's go back to our game controller. And where we have this, we added the escape key check over there to quit the application. We also will now want to add a check for if the player hits the letter R in the keyboard, which is a replay. So we'll do input get key. Let's see, is it key down? Or key code, I'm sorry, key code dot. And they actually have every letter of the alphabet defined. You can see A. Then they got alpha 0, 1, 2, 3, 5, 6, 7, 8, 9. Alt GR. What does Alt GR mean? Not really sure what that definition is. But anyways, we're going to go to R. The R key is defined just like that. Key code.R. We're going to do, and I believe it's a functionality. I saw it when I was watching some videos. There was a, I think there's a function called load scene or load level. Is it load level? Loads the level by its name or index. Okay, yeah, they call them levels. Is there something called scene? Yeah, I guess it's load level by its name or index. We're going to do it by name. Our level name, let's go back to Unity. our scene, which is our level. It's called gameplay. That's what I called it. Nothing fancy. So let's call it gameplay. Capitalization, I think, is important. So it's capital G, everything else is lowercase. Okay, it's saying here if you kept underlining it, and that's just a warning, but it would still work. Sometimes you get this where if you look at the function definition that's shown up there, it's got the word deprecated in brackets at the first line there, right after the little Unity icon. It says deprecated. What that means is it's no longer the preferred way to do it. They're going to eventually, could potentially phase it out in future revisions or updates of Unity. Right now they're on Unity 5. That's what I'm running here, Unity 5. And so it's a 2017 version, but I believe it's Unity 5. So it can still be used right now. I could use it. But if I didn't want to have to worry about down the road, let's say I continue to develop this game and it was a game you're working on for, like in big publishing houses, they could take years to develop a game. And if they update their Unity midstream, and they use a lot of deprecated functionality, one or two things could happen. Number one, they'd have to have a lot of code to be changed, and at that point, basically to update it to what the preferred method is. The other thing is, if that deprecated functionality was in fact completely removed by a Unity update, it would break their game. It would break their code. And so it's better to just go ahead and use whatever is recommended now, so that it's good for a few years usually, because by the time the new, what they're recommending to use is deprecated, it's probably going to be several releases beyond, so it won't really affect your development. So let's say in here, if we read this, it says at the very last line, it says application.load level string is obsolete. It says use scene manager.load scene. So that's what we're going to do. We're going to change that to scene dot load. Okay, so what's with the scene manager? What's going on here? So we're going to have to do a little search, because it's probably something that either we need to declare, unless it's part of the application object. Let's see. Again, I'm learning this as I go, so that's why I'm not. Yeah. Anyways, and I had a guy that popped in a video in one of my streams and typed a comment on one of the early streams I did. He was telling me to refer to some other website if I want to learn how to create Unity games, and it's like, yeah, that's all fine and dandy, but the whole purpose of doing this was for me to challenge myself and learn stuff on my own, because number one, I remember it better, and I get a better understanding of how things work when I figure out stuff, even if it takes hours on something simple. Once I figure it out, I've got it. So I don't want to, sometimes I don't like to just watch videos and have someone tell me exactly how to do it. Sometimes I will. I mean, if I want to move along, I will. But in this case, this is something simple. I don't need to reference a video for it. I should be able to just look it up in Unity here. Scene Manager. Okay. And this is a good thing. I'm kind of glad we encountered this, because this is something that you need to be aware of if you're doing your own Unity apps or creating something and you want to use some functionality you've seen in some video you watched, and it shows underneath the actual Unity object here, the Scene Manager, that it's a class, and it's in Unity Engine.Scene Management. Scene Management is the class. So what that means is we're going to have to add. Well, we can do one of two things. We can probably type out Unity Engine dot scene management dot scene manager, access to scene manager that way, dot load scene, that really long. But if you're using a better way to do it is you import that class or that function, that class up here. It's really a namespace, but classes are organized in what's called a namespace. And so we could say Unity Engine dot scene management. Okay, by doing that, see how scene manager lit up blue? That means it's now recognized as a valid object. Now, since we don't have to declare the scene manager, there's probably a static object or a static instance of scene manager, that object in the class scene management. So we should be able to just do that scene manager dot and use this function directly. Crap, I keep typing in crap that don't need to be there. Loads. Okay, so there's the load scene function that's showing up. So load scene, and then it's just in parentheses. You put in quotations the name of the scene. So that will by pressing R. That's all. That's the only line of code we need to reload our scene. Since it's already in memory, it should load a lot quicker the second time around. Like initially when the game launches, it's setting up some stuff for the resolution and allocating memory, loading all your game objects from your scene, and loading the scene itself with all its child objects. So it takes a little while, but once it's in memory, I'm sure it keeps a copy of that while your Unity project is running, and it should load it quicker the second time around. So we've got our two key codes defined: key code R, key code escape, and we just need to test it now. So let's go back to Unity. Let's run this. All right, so let's see if we can just get hit by bombs. We're at lives 2, 1. There we go, live 0. Game over. I might need to increase the size of that. It is hard to see on this 1920 by 1080. But anyways, you see it says press R to replay game. So let's try the R. Let's see what happens. There we go. So it seemed to load okay. Now one thing that didn't load right is look like our like we lost our directional light. That was kind of messed up. So we'll have to work on that. But anyways, that gives you an idea of how that all works. We'll probably stop here. That'll be it for this stream. I'm going to research a little bit about sound. I do have a folder here. I imported some free sound bits. And I was going to put maybe some background music and some sound effects when you fire and when it hits an enemy through an explosion, that kind of stuff. But that'll be next in the next video. Until then, take care.